Hey, hello everybody. Welcome to another class. Forgive me that I'm late today. I had a meeting in my work, so I could not join earlier. So let's go. Let me just see if everything is working fine first. Give me a second. I go here and I had a meeting in my work, so I could not join earlier. So let's go. Okay, looks like everything is okay. So let's follow our content. So we are going to the second class today. Let me close this and let me start a new one just in case. Actually, not going to use today. So let me do this. Ta-da-da. Oops, sorry. I want to play with this guy. This is the program that I use to do the screen record. It's called OBS Studio. Let me change this to the preview. So last class was just a opening state and explain how it goes. So today we're going to start the learning. And we will start with this file here. That will be 001, intro to computing. Like I said, I'm going to be focused on what I think in my life experience and as a professor and as a professional. What is very important, those things that I felt that I have to remember and I use daily. And today we talk about some basic concepts, but I think it's very important to understand. It's very, very basic. I will try to make sure that gets clear. Don't get scared because some of this just like it's just a preparation because later on we're gonna see more details about this, but we're gonna be connecting the dots. And it's very important that we really get everything that we are covering here because it's like a stair. Every new step requires all the previous one. So it's very important that we make sure that we understand every class to move to the next one. Otherwise, in some point, it's not start to make sense anymore, and it will be very difficult to keep going. So the first important concept here that I think is very basic is the idea of abstraction. Oh, sorry. Abstraction is something that everybody knows, everybody uses. It's just to make it formal because we're going to need a lot of abstraction in this training. So what is abstraction? I'm not going to give like a formal definition. I'm not a linguist, but abstraction basic is when we hide some complexity and we focus on what we need for some basic case, for some basic situation. One example, when we sit in a car and you start the engine, all the car, we have to spin the key. Today we press a button. So every time we press a button, there is abstraction happening there. We flush the toilet. We use a lever, something like lever, something like that. Something is happening under the hood. Something is happening behind the scene that for us is not relevant there. You are driving a car and you accelerate, or you want the car to gain speed. As a driver, we don't need to understand everything that happens in a car when we brake, when we speed, when we turn. We just want to know, okay, if I brake, I want my car to reduce speed or stop, completely depend. But almost nobody really knows what everything that happened. We have an idea, but only if you are like a mechanical engineer or something like that, you really know what is going on. So that is the idea of abstraction. Is almost everything that we are using, that we are doing, there is some extra lower level thing that is going on that most of the time we don't care. Because if to drive a car would be required for someone to get a license to really understand how a car works, only a handful of people will be able to drive. So the cars are making a way that we can look to the panel and see what is going on, speed, oil, temperature. But we have no idea what really happened inside the car to show us that information. When we turn on the air conditioner, turn off, we increase the fan speed. There is a lot of things happening in that car that give us that effect. As a user, as a driver, I don't need to know all those details. Of course, if I know, it will help me understand a little bit more. For example, if you are a race driver, for sure, a race driver has way more knowledge about cars than someone that just drives regularly. So is that why I put here that there is layers of abstraction? If you ask a med school student, how does a human heart works? We're gonna get explanation. If you get a high school student, we're gonna get this kind of information, level of detail, sorry. If you ask someone in the street, almost everyone has an idea. Well, the heart is an organ, is a muscle that pumps the body. But there is layers and layers and layers of abstraction. Even a doctor, most of the doctors, they don't know all the details. You have to go to a specialist. That's why there is a cardiologist. So that is the idea that almost everything, there is some abstraction behind, and there are levels of abstraction. So there is like plenty of example in our daily, like, and in computer it's not different. And it's very important, otherwise we're not going to be able to understand, to build, operate, and even maintain complex systems that nowadays every system is getting more and more and more complex because we are doing way more stuff than before. So why abstraction is so important? It's something that we all know, we already use. It's easy to understand. Well, we hide complex that is not needed. We can drive a car without being a mechanical engineer. We can use like a computer without being a computer engineer. There is a lot of things that happen every time we press a button, every time we type a key, every time we print something. So abstraction is a very important tool to allow us to use stuff, to learn new stuff. Because if we start to learn everything and try to go as deep as possible, it's very rare to have someone move on. Is that why our school system, we start to learn basic thing and then you're gonna dive in, more complex thing, we go to college and then you have masters and doctors and PhD, and then you can every time narrow down in a deeper layer of abstraction to understand things. Oh, sorry, let me go here to see. Okay. I hope the sound is still okay. Let me just test it. Hello, hello. Okay, sounds good. So coding is layers and layers and layers of abstraction. So is that why I want to make sure that we all understand. So today we're going to start to learn a little bit about this big illusion. Everything in a computer is an illusion because it's digital and you see. Sometimes the real world is not a real illusion, it's something is there. When you press like the gas in a car, there is change in the engine that more fuel will be burned, like and then the spin fast, and then the wheel will give us. How old are you, so? Why you choose to learn code at this age? Good question. I open a parenthesis because someone make a question. I think I tried to answer the last one. So I gonna put a parenthesis here. So I don't mind. I'm 54. And why you choose to learn code at this age? Well, I learned code when I was 14, 15. So the question would be why you choose to teach code at this age. So I think it's an asset. I guess in the era of AI, we can use AI tools to build software that is something that the entire market needs it. And then I think is a fundamental skill to have, because then more people will be able to understand and use AI and review and talk to it. So that is my idea. So my goal here is to provide a free opportunity for someone to experience something that going to university. So I had a background as a professor, so I hope I answer your question, but that was the idea. You can watch for the first class that I explain a little bit more on those concepts, but let's go back here. What I like to make sure that we all understand this idea of abstraction. For example, right now we are looking for this computer screen. You can hear my voice. You can see my, I hope, you can see my image there. Oops, let me see if I didn't mess with it. But actually, there is no letter A in my PC. There is no letter A in your PC. What we see here is an abstraction. In your screen, there are very small dots that is bright, is to show what looks like a letter A. It's not like in the paper that we write a A letter there, and we can, even the paper is abstraction, it's like ink in a paper. Okay, let me go back here. But this is, everything is illusion. We see letters because our screen is two non-little points that show us letters so we can read it. But in no computer, there is letter A. We're gonna learn today, in this class, how that abstraction happened. Because under the hood, in the computer world, is everything electronic. It's digital world. It's not like paper and colors and like it's everything is based on electricity basically. And so I hope abstraction concept is clear because we're going to talk about that later on. It's something that basically everyone knows. Now let's go a little bit deeper and I'm going to try to explain this concept. How, as I told this illusion, how a computer can store information. Because basically a computer is a machine that can process, store information, data, information. So I want to, like, imagine that you have an onion with, we are peeling that onion. I want to show one of those little things, like, to understand there is no magic. There is a lot of complex, a lot of things that was done before that we can use it, but if we can navigate the abstraction, it's very doable. It's easier than you think. If it's like, imagine that you are young and you say, oh, I want to drive a car, and someone gives you a book of mechanical engineer. You're gonna think, well, every driver is a genius because how come there is all this knowledge so I'd be able to drive a car? But that is far from the truth. It's the same with coding. Is what I'm trying to show you here. If you correctly use abstraction, coding, even today using using AI, is way simpler. It's one of the easiest professions that we can learn. And I think the market is going to learn that AI is very good, but cannot replace us. And then we're going to see a growth in demand for profession that they can do what I'm teaching here. That is my prediction. I may be wrong, but I put all my coins on this. So let's do, I put here just I can remember this example. So we'll see, and I use this example because when I was young, when I was learning, a teacher showed me this way, and that stuck in my mind and was good for me because it was kind of an example that I could understand how the information can be stored. Maybe today, disclaimer, maybe today this example does not make sense, but just giving some context. Back in the days, when you have like a crush or a date, it was not easy to talk, to hold hands and do the dating. So up to 18 years old, you had to really be careful because of the parents and all that. So maybe today you're gonna say, oh, this is silly. How come? There is no problem about that. We can just chat by phone and do a date and can meet and all that. So, but back in the day was a big deal. So the example is about two teenagers that they are dating, and imagine that they have very strict parents, so they cannot date by that age. In my time, up to 18 years old, you need authorization for the parents to date a girl. So that was the scenario. That is the case. So what I do here is I open this tool So it's a free tool, I guess, from Facebook built it called Scally Draw, and it's very good. So imagine like this. The situation is we have a teenager, doesn't matter the gender or the sex, that want to communicate with the partner. And then said, okay, let's use a light in my window. So imagine that initially we only have one light. And we will use that light to give a signal if I am at home or not. So if I am only using one light, how much information can we represent? One light has two stages, on or off. That is the foundation of everything that computer can do. So let's think this. Imagine that with just one light, oops, sorry, one light. What can you do? With one light, we have those options. We can have that light. Oops, sorry. Let me copy and paste. We can have the case one, the light is off. So that means I'm not at home. So if my girlfriend or boyfriend walk by my home, look my window and see no lights on, that means not home. If the light is on, that means, okay, I'm at home. So it's very clear that with one light, we can only represent two options, two states, two values, on and off. So one light is the idea of one bit, okay? I'm gonna talk about bit later on, but with one bit, we can only represent one state. This we could see like this. Oh, imagine that we have values. So it would be something like 0 and 1. Cool. So imagine that now this thing is getting more serious, and then the couple realize, oh, we have to add one extra information. We want to give a signal if the parents are at home. So with one light, I could just talk about, like, let's see here, like me, the person, okay? Now let's expand this. Let's now say, oh, we're gonna use two lights now. One and two. But these two lights now will represent more information. So it will be like me, the person, and the parents. Of course, you can use abstraction this. You can use it an example where we need to represent this. So with two lights, how many states or how much information can we represent? So let's see this. The two lights will be off. Only the parents' light will be on. Say, oh, the parents is at home, but I'm not. Maybe to let the partner know, oh, my parents is home. You can go there, maybe try a conversation or see what you can do, or at least you know that they are at home. So don't go inside or go to my window to give some gift or bring some letters or whatever. We could have a situation where only the person is at home and the parent are not. So this, I think, in this particular case, is the ideal situation. So the girlfriend or boyfriend is at home and the parents are not. So I can just, or me or wherever, I can just knock the door, go in, or sneak through the window, or let's just use our imagination, okay? And we have another situation that is like this. Both lights are on. So if both lights are on, that means I am at home and my parents not. And then that information can be used to, okay, I can go there, I can use the front door, I already be prepared to salute them and all that stuff. Or maybe I just go home. I bypass that day. Let's do this. This. Oops, sorry. And what happened here? We could have, like, imagine that we are convert this to numbers or options or values. We now have 4. With one light, we can only represent 2 states. With 2 lights, we can represent 4 states. So this may be good enough for that couple, but imagine that now, just to, as example, let's do this. Oh, sorry, I forgot to say something here. This is with 2 lights. Cool? Oh, there is something wrong here. 2 lights. Now let's see another example. Let's see if, okay, I want to give one extra piece of information. And let's use like 3 lights instead of just 2. Oh, let me do this. I copy this. And let's say, okay, now I want 3 lights. With 3 lights, we can add something else here. Let's just, for sake of example, let's do this. Parents, and maybe I'm busy or doing some homework. So we want to add some extra information here. But this could be anything, okay? Now we are using 1 light, 2 lights, and now 3 lights. Let's see how many options we do have. So the first one is all the 3 lights are off. The second one could be only the first light is on. Another option would be only the second light is on. Another option would be the first 2 lights are on. Oops. Another option would be only the first light. Try to do the exercise. You can pause the video here and try to yourself find all the combination. I know that most people watch this offline. We can have this, and then we can have the other combination. The first light and the last. Oh, I select everything. So be this one, this one. Could be just this one and this one. And of course, could be all lights. Let's see now how many options we do have. Look, now we have 8 situations. So this, I'm not home, my parents are not home, I'm not busy, so I'm in other place. I'm not home, my parents at home, but I'm busy. Maybe I'm doing some training, I'm the gym. I'm not home, but my parents are at home. I'm not home, but my parents home, but I'm busy. I am at home, my parents are not home, but I'm busy. So this is a good situation. The other one, at home but I'm busy, so don't bother me. Maybe try to do something else. I'm at home, but my partner at home, and then all three. So based on this information, we will look which are the case that interest us. And depending on the context, we can be interested in one another. What I like you to exercise now is, with one bit, we can represent two states. With 2 bits, we can represent 4. With 3 bits, we can represent 8. What if you use like 4 bits? We can do exercise here, so just to understand. Okay, let me do this. I will copy this, this, and this. I put here in the side. So now let's use 4 lights. So that means we'll have something like this. Come on, what happened here? Boom, boom. For me, in this example, doesn't matter what you are represented. That you think, okay, I have 4 lights. What are all the possible combinations? So let's start with, again, pause the video, get a paper, pen, and try to do yourself. And then you can continue. We can have only the first light, or the last light. We can have only the second light. So just to follow a partner here, we can have the first 2 lights on. We can have only the second light on. And then we can have the second and the last. Now we can have the second or third and the fourth light. How many we have here? 1, 2, 3, 4, 5, 6, 7. And then we can have, let's see, I guess I miss one here, right? All off, this on, this on, this 2 on. Now this, and this. We are missing actually like this. Let's do this. Oops, sorry. Let me create a space here. And then we can copy this. Oops, sorry. If I'm not mistaken, we're missing this case. Oh, this and... Oh, no, we are not. I guess we're good. We have this one. Did I get confused here? Oh, this and this. Okay, and then all. So now we have 1, 2, 3, 4, 5, 6, 7, 8. That is what I expected. But we still have to use the first light. So what happened is, basically it will be all this. Let me remove this here. But with those lights on. How many do you have now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So with 4 lights, let's put a table here, see if you can understand this. with one light, we have 2 states. With 2 lights, we have 4. With 3 lights, we have 8. With 4 lights, we have 16. Do you find any pattern here? We are double the number of states every time we add a new light. That is one reason that we can try now. Is that why memory goes by double? We have a 8 gigabytes, we have a 16, we have a 32, we have a 64. Why don't have 10, 11, 12, 13? Because the cost that make a memory bigger than the other one is to add one extra bit. And that one extra bit, double it, because as we can see here, we have whatever we have with one less bit. When we add one more bit, we add like all the combination with that bit on and off. So now you can answer a question that could be in an exam, could be in a certification, or in an interview. Some ask, oh, why memory size always double? Maybe there is some exception, because sometimes that part of that memory is used to something else, but generally speaking, always double. And then you can say, well, because to increase the memory size, we add one extra bit, and that extra bit will have the same combination as without it, with that bit on and off. So it's kind of, we can deduce the idea why memory is always double the size. So what happened here, look, we can think this way. Let me put this like I need the right place already. Oops. I missed some number here, right? 15. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I missed the 10. Okay, so 10. Okay. Imagine that they are perfectly aligned. So this is how a computer stores information. So memory is some electronic components that we have wires, we have capacitor, we have transistor, we have something that can store information about be on or off. Do you remember when I mentioned about levels of abstraction? In this level of abstraction, we are using like circles to represent lights, and yellow to tell the light is on, and white the wire is off. But of course, in a computer, there is no light. In some point, back in the day, it was valve, was kind of light, was on and off. We could turn it on and off to do all the coding, but today is different. There is a lot of complexity that there is a lot of like new thing going on. For example, quantum computer is going beyond one bit, be able to represent only 2 states. There is something else that added some complexity. So is that why you are in the early stage of quantum computer? So this is how a computer can store 16 numbers from 0 to 15. If we have like 4 wires and then we can have voltage in those wires, we can represent those numbers. If there is no voltage at all, it's 0. Another level of abstraction, if one of those wires we have like 0 to 2.4 volts, means that this guy is on. Everything else, if it, even better, from 0 to 2.4 volts is 0. From 2.4 to 5 is 1. So now is how we can use some electrical components to store information. So there is no numbers in our computer memory. There is no memory, or there is no number in a hard drive. What happened is a combination of on and off status to represent those numbers. For example, number 7 will have somewhere in the computer memory those bits where those 3 bits are on and this one was off. If we talk about the number 14, we'll have those 3 bits on and this bit off. There is always an extra layer of abstraction that is going to bring more complexity. I have been doing coding for a lot of times, more than 3 decades. And I cannot explain you down to the level of the metal. I have an idea, in some point I study about that, but in my daily work, I can do very advanced programs. I can build games, online application, mobile application, but I have no idea how this really happened. Like someone can be a world champion, drag car or Formula Indy or Formula One, Rally, but they don't understand mechanical engineering. He just know how to really drive the car fast. It's the same idea. That is where I want to make you all to understand that it's all a big illusion, abstraction, and we don't need to really understand all those details to do coding. And I can even go beyond and tell that with AI today, we are adding a new layer of abstraction where we can make a lot of complex things even easier. Is that why I hope this training can make everyone turn into a very good software engineer. Everyone will be able to build apps. Everyone will be able to understand how to talk with AI and get output that is useful. That is the idea of this training. And I think it's the best time ever to learn software engineer. Maybe there is not that explosive job as we have like a few years ago, where we are being getting reached by a recruiter every week. Now it's very rare, but there is still a lot of opportunity out there. You can even build your own product. You can build your own games and you can make money for that. Cool. And I'm pretty sure in a few years, the market will change. A lot of people will move away from software engineer, and those ones that keep pushing will be rewarded. I confess that it's a big correction because up to 3 years ago, everyone could just start to learn. You put a LinkedIn that was a junior developer and you look for jobs. It's the same thing as someone just join a law school or a med school and claim, oh, I'm a junior doctor, I'm a junior lawyer, please give me a job. It was so crazy up to 5 years ago that was happening. Someone was doing a boot camp for like 2 months, 3 months, 8 months, and then became a software engineer and make hundreds of thousands of dollars a year. And I knew that in some point the market will correct because it's not sustainable. So now, of course, there is a big shift, there is a big overcorrection, but I still believe it's a great area, way easier than many other ones to learn and to start. It is that why I'm providing this training. Okay, so let's go back. The goal here is to use this silly example that was interesting in my time. So abstraction, no? Or context. Like in that time, it was very hard to have a solo moment with your loved one or someone that you like it. And this could help. We could use some lights to provide information. Okay, so this is what I want to understand. That a computer can only understand and store zeros and one. And it's not even zeros one. It's voltage. It's capacitor on and off. It's light going one direction, the other one. Magnetic dots. So everything that, in some point, even paper. Like when I was start to learning, they have those punch cards. That was a piece of paper that you could turn on those bits, removing little slices, like pieces in the paper, to have information there. And then we have a bunch of those things that will become a program. Okay? But don't get scared. We don't need this knowledge to really do coding, but will help us to understand. Okay, let's see what else I put here for us. This is the example. So let's talk a little bit. Actually, no. Let's pause here for the class today. I don't want to have a very long class. So digest this, and then next class we come to understand a little bit more about the binary system that actually we are learning. I'm gonna just formalize what we learned here, because this is a binary system, because we only, the digit that we are using is 0 and 1. But remember, it's not 0 and 1. We talk, computer language, computer machine is 0 and 1. There is no 0 and 1. 0 and 1 is a representation, it's abstraction. It's two stages, on and off. Voltage in one range or another range. So some of those things. Of course, 0 and 1 is very convenient because we can understand easier. So, for example, imagine that I want to represent the number 14. The number 14 could be something like this. Let me go this. The first bit will be on, the second bit will be on, the third bit will be on, the fourth bit will be 0. So this is equal to 14. I want to represent 10. So 10 will be, the first bit is on, 0, 1, 0. So this is how a computer stores in memory the number 10. But we know it's not like this. There is no 0 and 1. In somewhere, we'll have an electronic component that has voltage or not, or there is some indication that that little part is on or off. And then when the computer is going to read this, say, oh, which number is this? 10. So he can understand. But a computer has no way to know what information is there unless we tell them. There's something else that we learn, okay? So with this table, a computer can, but do you know, like the number 14 in decimal in our numeric system, we only use 2 digits. For a computer, we use more. In this case, we use 4. We cannot represent 14 with just 1 bit. We cannot represent 14 with only 2 bits. 2 bits, we can go only to 0 and 4. We cannot represent 14 with only 3 bits. We can only go to maximum of like 7. Okay? We can represent with 4 bits because we can go all to the 8th from 0 to 15. Is that why we need a lot of computer memory to store all those numbers? Cool. Yeah, that was the idea of the today class. I want to show you this example. This has nothing to do with coding, but it's going to give us the foundation. Because remember, if you are a pilot to a race car driver, if you know a little bit more about mechanics, it's going to help you. If you understand the limit of the car, what happens when you brake, when you accelerate, and all that, will make you be more efficient. You can save the car, you can understand what happened, and then that is the idea here. Okay, it's a very basic class. Every university, there is a class like this, the first the first week. So that is why I bring this to you here. Make sure that you understand this idea is abstraction about how a computer can store information. And so far is what most computers, except the quantum computer one, deal with information. Cool? Well, see you next class. Sorry for being a bit late today, but was work related. And God bless you. See you. Bye.